directions, like for. So it's like in battery, we have 2 directions, and for the grid, we have 2 directions for the power energy, and for solar, it may be bigger or smaller than the load. So where is the extra power go? So there are combined all the possibilities. There are a lot of working modes to design in the inverter to satisfy the different applications. So different customer may have different requirements. And so the first one we will suggest, we will introduce is self-consumption. Self-consumption is like you want to independent from the grid, as because in some countries the power cost is very high. So in the daytime they use the solar to take the load, and however there may be extra power. So they will use the extra power to charge the battery. And in the midnight, when there is no solar, battery will discharge from the battery to use as less as the power from the grid. So for this working modes, you do not need to change any settings. When you get the inverter, because you can see in our monitor system, we can enable AC charge priority, and the forced discharge, and maybe you have peak shaving and a lot of settings. So if you want to use this, is like default modes from our manufacturer. You do not need to change any settings. The only setting you need to do is like the on-grid EOD. This is very important. For example, if you set 60% of the EOD, it means that when the battery discharge to 60%, it will not discharge anymore. So it's like for 40% of the power is used to like self-consumption. You charge, discharge.
Hello,
yes.
Yo.
And so for the 60%, it will be a backup. So especially in South Africa, when there is a lot of load sheddings, and you need to decide what is the setting you want. You want to keep like 60%, or if you like to keep 80% for the battery. So this, for the self-consumption, the settings like charge first disable, AC charge disable, forced discharge disable, and peak shaving disable. You disable all the other functions and just set the on-grid EOD that it can work. And so it's like from the solar, you use the solar to take load, take the to charge battery and feed into the grid. If the solar is not enough, since for the self-consumption mode, it's like we want to use as less as power from the grid. So if the solar is not enough, battery will be compensate the extra. Like if you have, for example, you have solar as here is 300 watts, and in this picture is enough, right? However, if you have like 800 watts load, the extra 400 will be from the battery. So in the self-consumption mode, it's like solar first go to the load, second go to the battery. If the solar is not enough, the solar go to the load, and the battery will compensate the other part. So we will not use power from the grid. This is the self-consumption mode. So do you have any questions for this mode? And if not, we will go to the next one. The second one is charge first. So charge first, you can understand it as the words. So for self-consumption, solar will be used to take load first. However, when you enable charge first, the solar power will be used to charge the battery first. It's also like in South Africa, because it have a lot of load sheddings. So once there is power from the solar, I may want to use it to charge battery first. So in this situation, you can enable charge first, and of course you can see there is actually in the monitor system there is a setting group, and I will show you in a minute. So you can see this is a monitor, the monitor system for 12 kilowatts. So this here you can set charge first. So you enable the charge first and choose the power you want to charge. For example, if you set 5 kilowatts and there is 8 kilowatts from the solar, then 5 kilowatts will charge the battery and the 3 kilowatts will take the load. Then stop charge first SOC is like where you want to stop, use charge first. For example, if you set 100 here and there is solar battery already reached the 100%, then the power will be used to take the load since the battery is already full. Or even if you set 90% here, then if the battery reach like 92%, then the solar power will be used to take load first. So this condition is to like stop the charge first. And this you can choose 3 periods to use the solar to charge the battery first. And during the charge first time, the battery will not discharge. So it's like always help you to keep the battery at the SOC you set. And let's see, we have a inverter online. So it's from here. Later we can, if you want, we can do some tests on the unit which is near me, and you can have more idea about the 12 kilowatt inverter. And then let's go back to the slide. So for charge first mode, it's like the battery is high priority. Solar will go to the battery and then go to the load. At last, it will go to the grid. And during priority charge time, the time you set, even maybe the battery reach the settings you get, battery will not discharge, because we think when you enable charge priority, then you think the battery is very important to keep the certain capacity. So we will not discharge during the setting time. So the related settings I just show, you have to enable charge first, choose the time, the SOC you want, and disable the others like AC charge, force discharge, and peak shaving. So of course, if you want to use AC charge, you can combine them. We can, for example, although you set charge priority, but you think the solar is not enough, then you can enable AC charge. Then the next one is AC charge. AC charge, there are two situations you may use the AC charge. One is that you want to charge the battery urgently, because as I just mentioned, the solar is not enough and you want to charge your battery very soon. Then you can enable AC charge. Also, in our monitor system, there is AC charge, I will show later. And there is another situation that you may do not have a solar panel. It's just you buy the system step by step, and you buy the inverter and the battery test, a battery first, but solar panel is not ready. Then you need to use the AC charge to charge your battery, and when there is load shedding, the battery will discharge. So in the LCD, you can also set the AC charge. Now, I put there is red. It's like before we only have AC charge according to time, but now we also support AC charge according to SOC and the voltage. So I will show here. We can see here is the AC charge function. So if you want to use AC charge, you have to enable them. And also I mentioned before, we only support AC charge according to time. So you choose the time you want to use AC charge and when to do the AC charge. But now we support two ways. One is according to the time, and the other is according to the SOC. So if you choose the time, then enable and choose the time, you need to select the time you want to use AC charge. So it will charge according to time. But if you choose according to SOC, and then you can see, you can set when to start SOC and stop. This is used to protect your battery, because sometimes we may worried about the battery stay low SOC for a long time. So in this situation, you may set, like I will set if start SOC at 4% and maybe stop at 20. So to keep your battery has a certain power inside. So there are two ways to have AC charge. And also we have a quick button here. You can start quick charge. Start quick charge here by this button, and it will charge your battery for 1 hour. Then you do not to do a lot of settings. This is an easy way to do the AC charge also. And then we have peak shaving function. Peak shaving is like in some area, the cost will be very high if you are higher than a certain, like if for example, if your power exceeds 10 kilowatt, and from 10 kilowatt to 20 kilowatt, it maybe have a higher cost. Then we can have peak shaving function. It's like when your power is, our CT will measure here. Our CT will measure the power you use from the grid. So it's like if you set peak shaving as 15 kilowatts, and now its consumption is 20 kilowatts, then our inverter will compensate 5 kilowatts to take the load, to avoid you use too much energy from the grid. It's like the peak value will cost you a lot of more. Also, like we have forced discharge here. One of the working modes, forced discharge. So if installers at the site and they find that they may want to, because the night there is the power is not enough or something, they want to do the discharge, then they can force discharge here to test charge function, AC charge function, discharge function is all right, to make sure the installation is okay. So it's most of us use this for test the connections. And in the documents, I also mentioned in future we will have PV cell to grid. This is another working mode. It's like you just because in some countries you cannot sell the power from the battery to the grid. You can just sell the PV. So in future we will have that function, and then we will have more details for that. There, I also put an inverter online. So the slides are here, and I also put an inverter online. So if you are interested, we can do some settings to change the like we can take some loads to see what is the self-consumption and what is the AC charge and charge priority. So let's see if you have any questions for the working modes, or if you want to want me to show some tests for you, then we can do it. So maybe I can show some tests for you, and let's go the working modes one by one, and so you can see. Let's see now. All settings should be disabled, so we can see that here. We can go from here. So AC charge is disabled. Charge first is disabled. And force discharge disabled, peak shaving disabled, and AC couple smart load are disabled. So this is what you get from the manufacturer. So it's a default mode, and then we can see it's 7 kilowatts from the PV, and so battery almost full. We can take some loads. Wait a minute. So we are here. I need to see if I can switch my camera here. So we are doing tests here. We have loads and the inverter and the battery. So we can take some loads. So you can see now what is the load that is long is 3 kilowatts, 4 kilowatts, and we can put more load here. It's 4 kilowatts. Okay, now it's okay, so you can see my monitor system. You can see my monitor system. We didn't change any PV input, so it's still 5 kilowatt, 5.8 kilowatt, and however, I just add the load to 8 kilowatt. So now when the solar just now was enough, and it will take the load and charge the battery. However, now I put more loads here, it's 8 kilowatt, and so the solar will take the load, and also the battery will take the load together. And meanwhile, we can see our settings for on-grid EOD here. So we can go to the discharge part, I think. So we can see here, now our setting on grade cut-off SOC is 20%. It means that when the SOC battery SOC is lower than 20%, it will stop discharge. So for the test, we can set 59%. Then we can see it will discharge very soon, stop discharging very soon. So with that, also, okay, I think maybe the maximum you can set is 90%. We have to. So now it's discharging from the battery, and so it wants to use the grid power now, and then I think we need several minutes to discharge from 96% to 90%. So I will turn off the solar. I'll put some more load. Wait a minute. I'm asking some people to help me. So we just turn off the PV to make it discharge fast, and when it decreases to 90%, the battery will stop discharge and use AC to take the load. Yes, so the compression for the inverter you get is already like a hybrid working mode. So you do not need to change any settings. Or we can see update the data. So now we can see that we turn off the PV, and now it's just discharge from the battery, and the battery is 94%. Yeah. So for our monitor system, the monitor update time will be 5 minutes. And if you press here, okay, you can see. So there is no PV now. It just use the battery to take the load. We can also take more loads. Let me see yes, we can put more loads to make it faster to 90%. And Yes, because there is maybe some delay from the monitor system, and I think will be discharged to 90% very soon. So it's in this self-consumption mode, if there is solar, it will use solar to take the load. However, if there is no solar, it will use battery to take the load. And you can set the cut-off SOC to keep certain battery inside. This is a self-consumption mode. I think for most of the applications, self-consumption mode is combined with the on-grid EOD. If you have load shading, you can set a little bit higher EOD that it can work with your system. So we have big battery capacity, like some time to discharge. So we can see now the battery. So now the battery is 92%. So after it's discharged to 90, it will stop discharging. Now it's 92. So also you can, as I show you the settings on the monitor system, you can also do the settings here. We have basic charge, discharge, and in the charge tab, there is charge for AC charge, and then you go here. You can set charge first, charge priority, and we go to AC charge. We can go to discharge to like force discharge and setting the discharge time, and also we can see that we can set on-grid cut-off here 19%. I was just setting that in the monitor system. So let's go back to see. It's still 91 now. It's 91%. Okay, so it go to 90 and the system begin to use the AC to take the load. So at 90%, it stopped discharging. And then we can do some other change. So that is the self-consumption mode and the EOD. Then we can try some like charge priority. We can test. So right here.
Limit discharge.
So like we have charge first here. Now it's disabled. If we enable discharge and so we can see the time in this inverter Chinese time. So yes, it's Chinese time is 4 p.m. So we can set the time. We have also to set the time here. Yes, I think that we need to set. So first we have to enable it. Then we chose charge first SOC to charge to 100%, and the time now is from 4 p.m. to 5 p.m. Now I turn on turn on the PV. You can see the monitor LCD because monitor is lower than that. So we can see here, it's like we have 5 kilowatts from the solar panel, and although there is load now, but we use the solar power to charge the battery. So let's see in the monitor system. Oh, you can see the monitor system too. It's used there is 5 kilowatt from the solar, and it's used to charge the battery, and so the grid will use to take the load. So in charge first mode, the solar goes to battery first, and then we can try to change this setting, the 5 kilowatts. Let's see, we set it to 4 kilowatt, and I take a little bit more loads. Try with that 3 kilowatts. So you can see in the monitor system now there are still 5 kilowatts from the solar. However, 3 kilowatts were used to charge the battery, and then 2 kilowatts were used to take the load. So we can set a little bit more load. So now we can see that still it always keeps 3 kilowatts to charge battery, and then the others go to take load. If the power is not enough, solar and the grid will take this load. So battery will not discharge. And you see it's still in the PV first charge time. So if I turn off the PV, the grid will be used to take load, and the battery will not discharge. So we can try to turn off the PV now. So you see now, I just turn off the PV. There is almost no PV power now, and during this period, if there is not solar enough, the grid will take the load, and the PV the battery will not discharge. I think that is so this is the charge first. And also there is like, you can also, when you have a system, you can try with AC charge. It's very easy. You enable it. You for example, if you chose according to time, then you chose the time, then it will use the AC to charge the battery. And if you want to protect your battery from low SOC or low voltage, then you can set according to the SOC. and you choose the start SOC and stop SOC. Then if your battery is lower than this setting, it will use the AC to charge your battery. And also we can disable PV charge and set up forced discharge. We can read, and we can test like forced discharge. We disable charge first. And if we disable it, it's like now it's in self-consumption mode. So the battery, I think now is it's lower than 19%, so it will not discharge. Then we can set enable discharge, forced discharge. So now we enabled forced discharge. Test the settings. So I think maybe we need to also change the settings here on grid security.
Rồi, nó phải cho phép ấy.
Wait a minute, let me check the inverter LCD side.
Xong bên này đang sao lối
So now you can see that the inverter is discharging according to our settings. I think it's discharging 4.5 kilowatts, right? Yes, yes. In the LCD, it's discharging according to our setting. But yeah. Okay. So you see in the monitor system now it shows that it's discharged at 4.5 kilowatts. It's according to the setting. Check the setting. So if you set force discharge, it will discharge at the power you set. It's not according to your load. So if you want to discharge bigger power, you can set a little discharge. Force discharge. So we set So you see, I set 4.5 kilowatts here for discharge, and set the right time. Then the inverter will begin to discharge at 4.5 kilowatts. It may take like 2 minutes to inverter need to start that the grid. So with some need to wait like 1 or 2 minutes for that. Then it will discharge. So basically, you can do all settings in the maintenance page, and also all these settings are available in the LCD. You can do both ways, and I think it's on the monitor system. It's easier to set, like AC charge first, and also force discharge, which you may use in your installation. So I think I will mainly display this test. If you want more, you can let me know. And let's see if you have any other questions. Oh, you mean I see a question that 7 put in the group. It's like how can someone test the output CT? That is a good question. It's like you can also test if the CT works in like use force discharge, because you know that you are discharged from the for example, you can set force discharge 1 kilowatt and 3 kilowatt. So the change here may be based on your load. If there is no load, then if you discharge 1 kilowatt from the battery, then it will if there is no solar, no load, then the export power will be 1 kilowatt. If you discharge 3 kilowatts, then the export power will be 3 kilowatts. It means your city installation is right. And also we have a function like if you find your city installation is wrong, you can go to the setting. Let me find it. You can set in the monitor system. Then you do not need to go back to the site if the city installation is wrong. Measurement is CT and so you can see here CT direction reverse. So if you find your CT is wrong and you can enable it, then the calculation will be right. So you do not need to go back to the site. If you want to update your firmware for now, you have to ask the distributor to get the verified code. And however, we are doing for next version of our app, we will not ask you to input the verified code. You just need to choose the model you have, and then you can update. I think for now I see another question, that 10 kilowatt installation. We test the interruption time within 20 milliseconds, which means that your device should be okay with that. You can contact our local technical support people to say if you can have an update to solve it. I think it's like we optimize it like last month or 2 months ago. You can try an update to see if you can solve the problem. So the battery is still is charging. I go to turn off the load. And let's say if you have more questions or you need to have to do some tests to understand the system, and I can do, because now I'm with the system. We have PV input, we have battery, and we have loads. Okay, if there is no more questions, I think we can finish here.
Hello.
Yes.
I asked a question about smart loads.
Ah, okay. In the group? Let's go back to the, I didn't see the smart load question. Did you put it in the group?
Yes, I did. Could you explain how the smart loads application works, please?
Okay. We have another presentation. Wait a minute. I will show you for the smart load. So there is another presentation which introduced the smart load. So smart load is like if you have a very heavy load and you do not want to take this load when there is not enough battery, and then you can turn off it. So there is a picture. It's like you can set when to start it. It's like there are two conditions. The solar power is bigger than the value you set, and you can see here, this is LCP. So start PV power is like when the solar power will be is bigger than the setting, and also there is a start voltage it's like or start SOC. Depends on you choose SOC to control or choose voltage to control. For example, you can set like here 5 kilowatts and 50%. So when the solar power is higher than 5 kilowatts, and when the SOC of the battery is higher than 50%, the load here will be on, and then there is a top one. So you can see there is an end SOC. So if the SOC is lower than the end SOC, then the load will be turned off. If you want the load always on when there is grid, then you can enable on grid always on. Then if there is grid, no matter what is the SOC, what is the solar power, the smart load will be always on. And if you didn't choose this one, then the smart on off will be set by the solar power and the battery SOC. Right.
Thank you.
And actually, also you have to connect your smart load to the generator port. Then we can turn on and turn off it. Yeah, welcome. So you connect your heavy load to the generator port, and you set the PV power, the SOC, start SOC, and then SOC here. Then it can work. It can turn on off the load according to your setting and the power.
Thank you.
So let's see, you have any more questions? Okay, and maybe we can end here. So also, as you know that if you join the training, you can leave your email to our sales, and we will have credit for you. Then in the end of the year, we will get who gets the most credit. We will give the inverter for gift. I see Miao Miao, you can post another picture here. Then I think we can finish it. You can leave your email to our sales.
Yes, right. For those who have been already enrolled in our installer reward program, please text me after the training. I will get your credits for training done today. And if you haven't enrolled for the installer reward program, you can do it now. We have this great program designed for installers in South Africa to support your hard work, and also in the meantime to help promote LuxPower brands in social media. So you're welcome to contact me for the details if you don't have it. And thank you very much for today's training with us, and I will send the playback link in the groups shortly. Thank you very much. Have a good day.
Thank you. Have a good day. Bye.